Long before the RMS Titanic ever entered the Atlantic Ocean, its story began with steel. Please subscribe. Beneath the luxury, the engines, and the famous decks was a massive structural shell made from thousands of steel plates, carefully assembled together. These plates formed the whole of the outer body of the ship, and they were essential to Titanic's strength, shape, and ability to survive the harsh conditions of the sea. At the beginning of the 20th century, steel had become one of the most important materials in shipbuilding. Compared to earlier materials such as iron or wood, steel offered greater strength, flexibility, and durability. For a ship as large as Titanic, using steel was not simply an option, it was necessary. The hull of Titanic was constructed from large steel plates attached to an internal framework of beams and supports. These plates created the outer skin of the ship, forming the barrier between the ocean and everything inside. Their arrangement had to be precise because every plate contributed to the overall strength of the structure. Each steel plate was manufactured to specific dimensions and then shaped to fit different sections of the hull. Since the ship's body curved and changed form along its length, the plates could not all be identical. Some needed to bend around the bow, others around the stern, while many formed the longside sections of the vessel. Once prepared, the plates were attached to the framework using thousands of rivets. Riveting was one of the defining construction methods of the era. Workers heated rivets until they became extremely hot, inserted them through holes in overlapping plates, and then hammered them into place. As the rivets cooled, they tightened, locking the steel together into one connected structure. The process required teamwork and precision. Teams of workers operated in coordination, passing hot rivets quickly before they cooled. The skill of Titanic meant that this process was repeated countless times across the entire hull, creating one of the largest steel structures ever built at that time. The thickness of the steel plates varied, depending on their location. Areas exposed to greater stress or water pressure often required thicker plating. Engineers had to consider the forces the ship would experience while crossing the Atlantic, including waves, vibration, cargo weight, and engine movement. Another important factor was flexibility. While the hull needed to be strong, it also needed to flex slightly with the motion of the ocean. A completely rigid structure could crack under stress. The combination of steel plating and internal supports allowed Titanic to maintain both strength and controlled flexibility. The hull was not just a single shell. Beneath the visible plating existed layers of structural reinforcement, including beams, frames, and the double bottom system. Together, these components distributed forces throughout the ship, helping maintain stability and integrity during the voyage. From an engineering perspective, the use of steel represented modern industrial technology. Titanic was built during a time when shipbuilding was transitioning into large-scale industrial production. Massive shipyards, heavy machinery, and organized labor made it possible to construct vessels of unprecedented size. The appearance of the steel hull also reflected this industrial era. During construction, Titanic's unfinished structure looked like a giant framework of metal rising above the shipyard, gradually covered plate by plate as the hull took shape. Another challenge engineers faced was balancing weight and strength. Thicker steel increased durability, but also added weight. Designers had to calculate how much material was needed to ensure safety without making the ship unnecessarily heavy. Looking back, the steel plates of the RMS Titanic revealed the enormous scale of effort involved in creating the ship. Every section of the hull represented planning, labor, and industrial engineering working together on a massive level. They also remind us that Titanic was not only a luxury liner, it was an industrial achievement. Beneath the elegant interiors was a structure built from raw materials shaped by thousands of workers using the technology of their time. More than a century later, Titanic's steel hull remains one of the most discussed aspects of its construction. Historians and engineers continue studying how the materials, design choices, and building methods reflected both the strengths and limitations of early 20th century engineering. In the end, the steel plates used in the hull of the RMS Titanic were more than pieces of metal. They were the skin of the ship, the structure that carried its weight across the Atlantic, the foundation of one of history's greatest engineering projects. And plate by plate, rivet by rivet, they formed the body of Titanic through steel, industry, and the ambition of an era.